All right. So now let's go and get into the next problem, which was the graphing. So one of the things that, so one of the students asked was to graph this. And so a lot of times people, once they get familiar with completing the square, they go ahead and default to completing the square. But in this problem, I probably wouldn't say completing the square would probably be my easiest. And it really kind of depends on what you need to do for graphing. If you just need a general shape of the graph, what I would do is try to see if you can identify the X and the Y intercepts, right? I think that's going to be the easiest either for a line and or really for anything. If you can graph, and we'll kind of come back to this actually, another problem is finding the X and the Y intercept. So if I wanted to graph this, again, just say, I don't know why we need to graph it for, some kind of problem, but I think one of the easiest thing to do is find the X-intercepts and find the Y-intercept. Now, again, the X-intercept is when Y is equal to 0, right? So in that case, we're just going to do 0 equals x squared plus 3x plus 2. And therefore, you can factor this to give you x plus 2 times x plus 1. And therefore, now I can say x equals -2 and x equals -1. So those are going to be my x intercepts. So that's a -1, sorry. So I'll do -2 and -1. And then the y-intercept is going to be when x equals 0. So I have y equals 0 squared plus 3 times 0 plus 2, which y equals 2. Okay. Now again, I know that a is going to be 1, so it's going to be positive. That means my parabola is going to be opening up. The problem with this, using this method, is you're not going to know where the vertex is. But again, if our goal is just to have a general idea of what the graph looks like, this typically is going to satisfy. However, for many of you that have been in Algebra 2, pre-calculus, and calculus, you realize that finding that vertex or that max or the min of the quadratic is typically pretty important, and usually it's something that we need to find. So we can either use the find the axis of symmetry, doing opposite of b divided by 2 times a, or we could complete the square. So in this case, I'm just going to focus on completing the square, which is basically going to be taking my b divided by 2 and squaring it. So in this case, I'll take y equals x squared plus 3x. My b divided by 2 squared is going to be 3 divided by 2 squared, which is going to be a 9/4. So I'm going to add a 9/4. But again, remember, if I'm going to add a 9/4, then I need to subtract 9/4. And then I'm going to add that to 2. But I'm going to change a 2 equal to a 4/2. I'm sorry, I'm not going to change that to a 4/2. I'm going to change that to an 8/4. Because again, I want this fraction to have the same denominator, right? 2 is the same thing as 8/4. So I'm just going to rewrite this as a 8/4. So now I recognize this to be a perfect square trinomial. That's what completing the square does. And one thing that you can recognize is what two numbers multiply, or what number multiplies to give you 9/4, but then adds to give you 3. If you look at the b divided by 2, it's just b divided by 2. That's what it is. And then you just use the same term. If it's positive, then it's positive. If this was negative, then it'd be a negative. But again, I'm not getting into a very descriptive completing the square tutorial here. And then this case would be a negative. Oops, I already have a negative. This would be a 1/4. Okay, and now you can see that my vertex is going to be a -3/2, comma, -1/4. And again, you could go ahead and graph this. And again, if you look at my graph, like that kind of makes sense, like -1/2, right, down -1/4. So it looks like my graph is going to be relatively good. The problem with this is it doesn't give you those x and y intercepts like this equation did. So it really just kind of depends on what you need to do